Oxidation-reduction reactions. These types of reactions involve the transfer of electrons. And sometimes for short they're called redox reaction, which always reminds me of Redbox. And that makes me realize that the movie I rented for my kids on Saturday, I forgot again to take back. Dang. Okay. Redox reactions are very common. Iron rusting is a redox reaction. If you go to the hair salon and get your hair bleached, that's a redox reaction. If you use batteries, and I'm willing to bet pretty much everyone in this class has something in their pocket with batteries in it, that's a redox reaction. So they're really important. Many of them involve something reacting with oxygen, but you can have some that don't involve that. So here's some examples. Hydrogen gas and oxygen gas reacting to form water. That's the reaction that powers the space shuttle. Iron and oxygen to form iron 3 oxide. That's what happens when iron rusts. And methane reacting with oxygen to form carbon dioxide in water. That's the combustion of natural gas. If you have a gas stove, that's what's happening when you light the burner. Redox reactions are generally pretty useful reactions. There are some that don't involve oxygen. Sodium reacting with chlorine gas to form sodium chloride salt, the solid. This doesn't involve oxygen, but it is a redox reaction. So the fundamental definitions of oxidation and reduction. Oxidation is the loss of electrons. Reduction is the gain of electrons. And again, that's taking two things and two other things and having to keep them connected to each other in the same way. So here we have another mnemonic, oil rig. So oil rig, oxidation is loss of electrons. Reduction is gain of electrons. They're called oxidation-reduction reactions because you can't have oxidation by itself. You can't have reduction by itself. The electrons have to come from somewhere and they have to go somewhere. So oxidation and reduction always occurs together. For now, you don't need to predict products or anything like that. We just want you to recognize, oh, that is an oxidation-reduction reaction. And these are the three things to keep in mind. If you have some substance reacting with elemental oxygen, it's reacting with O2, it's going to be an oxidation-reduction reaction. If you have a metal reacting with a nonmetal, that's a redox reaction. More generally, if you have one substance transferring electrons to another substance. So look at some examples. This is the sort of thing you should be able to do for the test a week from Thursday. Which of these are redox reactions? Well, here we have lithium, a metal, reacting with chlorine, a nonmetal. So that was one of them, right? A metal reacting with a nonmetal. So that one's going to be a redox reaction. A way I like to look at it is, here I have two elements, and here I have an ionic compound. So in that ionic compound, I have lithium ions, and I have chloride ions. Over here, was lithium an ion or an atom? Over here, it's an atom. How does an atom become an ion? By gaining or losing electrons. If you have electrons being gained and lost, you have a redox reaction. So if you see things that are elements, they're atoms on one side and they're ions on the other, that's another way. So this is a redox reaction. How about this one? What's happening to aluminum? It's going from an atom to an ion, and tin is going from an ion to an atom. Are electrons being transferred? Yep, that's a redox reaction. How about this one? Lead nitrate, lithium chloride, lead chloride and lithium nitrate. So is lead an ion over here? Yeah, it's part of an ionic compound. Is lead an ion over here? Yeah. How about nitrate? This is an ion, and there it's an ion. Lithium's an ion, and it's still an ion, and chloride's an ion, and chloride's an ion. There's no electrons being transferred. These guys were ions, and what's happening is when we mix, the lead and the chloride like each other, and they go off to a corner of the party. So is this a redox reaction? No. It's a precipitation reaction, but it's not a redox. How about carbon reacting with oxygen to form CO2? Yeah. Anything reacting with oxygen is going to be a redox reaction. In fact, that's where the term oxidation originally came from, was gaining oxygen. This is what's called a combustion reaction, something burning. And something burning is always an oxidation-reduction reaction. Any questions? So combustion reactions are a type of redox reactions. All combustion reactions are redox reactions, but not all redox reactions are combustion reactions. Just like all men are human, but not all humans are men, right? So these are characterized by something reacting with oxygen, and it's going to form one or more oxygen-containing compounds, often water. Combustion reactions are exothermic. Exothermic means heat is being given off. That's why we burn natural gas in our stoves, because it makes heat, and we can use that to heat water and make spaghetti. When we have compounds that contain just carbon and hydrogen, or carbon, hydrogen, and oxygen, they're always going to form the same two products, carbon dioxide and water, when they combust. So, ethanol. Ethanol is the alcohol in alcoholic beverages. That can combust to form carbon dioxide and water. The octane in gasoline reacts. Here's octane C8H18. This reacts with water to form carbon dioxide and water. So if you have a reactant that's just carbon and hydrogen, or carbon, hydrogen, and oxygen, we can write for, reactions for that, equations. So write a balanced equation for the combustion of liquid pentane, a component of gasoline. So we're giving you the formula there because we haven't taught you how to name pentane or write its formula. Combustion means reacting with oxygen. So to write this equation, I'm going to start with the C5H12. And we're just going to practice with our state symbols. It says it's a liquid. Combustion tells me that the other reactant is oxygen. What state is oxygen in normally? It's a gas. Here I have a compound that's carbon and hydrogen reacting with oxygen. I memorized the products, CO2 and water. What's the normal state of CO2? It's a gas. Now, at room temperature, water is a liquid, isn't it? But if I'm burning gasoline, is this going to be at room temperature? Well, it's going to be hot. So what's a good guess for the state on water? A gas. So I've got my skeletal equation. I need to balance this. So here I've got 5 carbons, and I need 5 carbons over here. So I'll put a 5 there. And I've got 12 hydrogens, and over here I have 2. So let's make that a 6, right? And then I have to count up oxygens. Here I have 5 times 2, there's 10 oxygens from that guy, and 6 from this one. And that adds up to 16 oxygens, which is a nice even number, so I don't have to do anything fancy. So I need an 8 here. Any questions?